In the first part of the lecture on functions, we'll learn to recognise the range and domain and to draw a mapping diagram. So first of all, perhaps we should ask the question, what is a function? Well, a neat way of imagining how a function works is to consider it as a type of machine, and we'll draw that by a little box in the middle here. So on the left-hand side, we're going to accept some kind of input. Let's imagine that we've got some numbers stacked up, ready to be processed by this machine. So we'll take, say, 4 consecutive integers, 1, 2, 3, and 4. So what we're going to do is process this stack of numbers in our processing machine. So we'll take those one by one and we'll write the output on the right-hand side here. So our output, if we input the 1 first, let's say we get an output of 2. Input the 2, we get an output of 4. Input the 3, we get an output of 6. And input the 4, and we get an output of 8. So our machine has now processed all of the numbers on the left-hand side that we input. And it's produced an output, 2, 4, 6, and 8. Let's give our machine a symbol. We'll call it F. If we call all of the values on the left-hand side X, let's say, what our machine does is it applies an operation to X. We'll call that F of X. And the output is another set of values, which you can see on the right-hand side. The input on the left-hand side has a special name, and this is called the domain of the function. And we can give that a label, such as A. So let's say the set A is equal to 1, 2, 3, and 4. So this is called the domain of our function. They're the numbers that we input into the function machine. And the output, we could call that the range. So let's say the range is set B, and that's equal to 2, 4, 6, 8. So what our function does is it converts the domain given by set A into the range which is given by set B. So we can write something like the function f is such that it maps set A onto set B. So what's the actual operation that performs this? How do we know what the rule is? Well, it should be obvious in this case that we're doubling the input values. So what we're saying is that our function is such that x maps onto 2x. So whatever value of x we choose as the input, it's doubled by the machine, and the output is 2x. In this case, our domain is restricted to these 4 values. But of course, if we wanted to, we could extend that domain. So we could take it from -10 to +10 and input the integer values, or we could input continuous values. We can define our domain as we wish. And we'd always get a range which corresponds to that given domain under the operation x maps onto 2x. We can also write this as f of x equals 2x. So hopefully that gives you a general idea of what a function is, some of the terminology that we use, and how the function converts values in the domain to an output, which is the range of the function operating on that domain. We need to be really precise if we wanted to communicate this information to somebody else so that they could take this function and generate exactly the same range that we've generated. What about if we wrote something like x is a real number, is that going to help the person recreate the range? Well, it's going to be absolutely useless, isn't it? Because a real number could be anything between positive and negative infinity. It could be an integer, it could be a fraction, or it could be some recurring decimal. We have no idea what it could be. So that's not actually going to help us recreate this specific range b from our given function. So how about if we wrote something like this? F of x equals 2x, and x is greater than or equal to 1, less than or equal to 4. But hang on a minute, we haven't specified what type of number x is, because all we've said there is that x is something that's between 1 and 4. It could include 1, it could include 4, but it says nothing about what's in between. It could be, for example, 1.003769 or 2.538 or something like that. So we need to further qualify this in some way. So we need to state that x is an integer. So we can write that x is an element of the set of integers, which is given the big symbol z. So knowing that, with these three pieces of information, f of x is equal to 2x, x is greater than or equal to 1, less than or equal to 4, and x is an integer, there's now only one possible outcome when we apply this function to the set of values that are in our domain. So we're applying f of x to the domain which contains the set of values 1, 2, 3 and 4, which is defined exactly by this inequality here. And we also know that x is an integer, so it can only take values of 1, 2, 3 and 4. So with this information here, that's going to precisely recreate the range that we want of the values 2, 4, 6 and 8. If we just sketch out our numbers again, set A, and this is our domain, and we had the numbers 1, 2, 3 and 4, and our output, set B, which we called the range, contained the values 2, 4, 6 and 8. Our mapping diagram then is simply a diagram which illustrates how these values in the domain map onto the range. So 1 maps onto 2, 2 maps onto 4, 3 maps onto 6, 4 maps onto 8, under the operation f of x maps onto 2x. So now you know what the domain is, you know what the range is, and you know what a mapping diagram is and how to draw it. The mapping diagram simply shows how the values in the domain are connected to the set of values in the range, which of course is produced by the specific definition of the function. Okay, you should now have a go at the multiple choice question for this subsection.